Hi everybody, today we're going to talk about the long division algorithm. This is the algorithm that you learned for dividing when you were in 3rd, 4th, 5th grade. It gives some people fits. A lot of people are intimidated by it, but I'm just going to go ahead and tell you that the more sure you are of your addition facts and your multiplication facts, the easier this process will be for you. So if you're teaching this to a child or a group of students, then you want to make sure that they are really comfortable adding and subtracting and multiplying before you teach them this algorithm, because this algorithm requires them to do all of those things plus a little more. Let's go ahead and take a look at just the basic algorithm. So we're going to divide 672 divided by 5. And of course, you know that whatever comes before the division symbol is the dividend, and whatever comes after is the divisor. So we want to see how many times 5 divides 672, or we want to see how many times 5 goes into 672. So, you know, sometimes we call this the doghouse. The 672 goes under the doghouse, and the 5 goes outside. Please be aware and do not teach children that the big number goes inside and the small number goes outside. That's not the way to teach it, because when they start converting fractions to decimals, that will change. The way you teach it is the first number goes inside the doghouse and the second number goes outside. So the long division algorithm is that we look at the divisor and we look at the first digit in our dividend and we say, how many times will 5 go into 6? Well, I know 5 times 1 is 5, but 5 times 2 is 10, so it won't go in 2 times, it will only go in 1 time. So then we put a 1 up here. That is our guess. You need to make it clear to students that this is a guess and this might have to change. It depends on the numbers. But this is just your best starting place. So we think that 5 will go into 6 1 time. Now we multiply back. 1 times 5 is 5, and there's 1 left over. So 1 times 5 is 5, and then you subtract, and there's 1 left over. And that means that 5 did go into 6 1 whole time. Okay, now we want to pull down the next number. Now you can only pull down 1 number at a time, so make sure students know that you can't pull down 2 numbers. Even if you need 2 numbers to make the process work, you can only get 1 at a time. So here we've pulled down a 7. Now we say, how many times will 5 go into 17? Well, 5 times 3 is 15, but 5 times 4 is 20, so it won't go in 4 times, it will only go in 3 times. This 3 is going to go right here above the 7. And now we're going to multiply back. So 3 times 5 is 15, and now you subtract. 5 went into 17 3 whole times with 2 left over. Okay, now we can pull down the next number. And how many times will 5 go into 22? Well, 5 times 4 is 20, but 5 times 5 is 25. So 5 will go into 22 only 4 times. And now we multiply back, and we see there are 2 left over. So 5 went into 22 4 whole times with 2 left over. Now there's nothing left to pull down. So that means that we have reached the end of the division process, and this 2 is a remainder. 5 went into 672 134 whole times, and it left a remainder of 2. So for right now, we're just going to write R2, and we can say that 672 divided by 5 is 134, remainder 2. Now let's talk about some things that can go wrong in the division process. Because in the last example we did, everything went right on the first try, and it seemed so easy. And when it's like that, you think, well, how could this ever be hard? Well, it can be hard lots of ways, and so we need to think about all the ways it can go wrong and be able to tell students how to fix the problem when something goes wrong. So one thing that can go wrong is, what if the divisor is too big to go into the first digit under the doghouse? So something like this. Let's divide 763 divided by 8. Well, we set it up with the 763 under the doghouse and the 8 outside. And then we say, well, how many times will 8 go into 7? Well, 8 is too big to go into 7, so we don't want to put anything on top of the 7. Instead, we're going to take the first 2 digits at once. And now we'll have to ask ourselves, how many times will 8 go into 76? And we know that 8 times 9 is 72. So we can say that 8 will go into 76 9 whole times, multiply back, and subtract, and we see that there are 4 left over. So 8 goes into 76 9 whole times with 4 left over. And now we're ready to pull down. And now we have to ask ourselves, how many times will 8 go into 43? Well, 8 times 5 is 40, but 8 times 6 is 48. So 8 will only go into 43 5 times, and when we multiply back, we see that there are 3 left over. And there's nothing left to pull down, so this 3 is a remainder, and now we can say that 763 divided by 8 is 95, remainder 3. Another thing that could go wrong is we could make a bad guess. So what if you make a guess and you put your number on the top line, but after you multiply back, the number you get is too big to subtract? So let's take a look at 465 divided by 8. So here we have it set up, and now notice that 8 won't go into 4, so we'll have to take the 46 at one time. So how many times will 8 go into 46? And let's say that just for a second you forget your times tables and you think maybe 8 will go into 46 6 times. So when you multiply back, 6 times 8 is 48. And you're not going to be able to subtract. So of course the 48 is too big, and that means that 6 was too big of a guess. What we need to do is erase that and try again. Everybody who's doing long division needs to have a good eraser on their pencil, and they need to be willing to make mistakes. So when you're teaching long division, the students need to understand that the guessing and checking is part of the process. Just because we had to erase our 6 does not mean really that we made a mistake. It means that we figured out that what we were doing wasn't working and we had to go back and try something else. That's part of this process. So we said 6 was too big, let's try 5. So now 5 times 8 is 40, and so that means 8 goes into 46 5 whole times with 6 left over. And now we can pull down the 5, and 8 will go into 65 8 times. Multiply back, 8 times 8 is 64, and we have 1 left over. 65 minus 64 is 1. So now we can say that 465 divided by 8 is 58, remainder 1. And here's another problem students run into. What if I go through the guessing process and then I multiply back, and after I subtract, the number I have is still bigger than the divisor? That's a problem, because then when we pull down, then we have a mess. So let's try dividing 375 divided by 7. Okay, so we'll say 7 won't go into 3, therefore we're going to have to deal with 37. So let's say again that we've forgotten our times table for just a minute, and we think 7 will go into 37 4 times. Now when you multiply back, you can see that we can subtract here and get a positive number, so it's not the same problem as last time. But when we do the subtraction, 37 minus 28 is 9, and now that's bigger than 7. The number that we have here should be smaller than the divisor, because you can see what would happen if I went ahead and pulled down the 5, then I'd really be stuck, because 7 would go into 95 more than 10 times, but I only have room for 1 digit. So this is where we need to back up. We need to say the 9 is too big. So we're going to go back and guess again. If the 9 is too big, that means this number was too small, and that means that our guess was too small. So erase all of that, and let's go up a number. And now when we multiply back, 5 times 7 is 35, and we can see that there are 2 left over. So 7 went into 37 5 times with 2 left over. Now we're ready to pull down, and 7 will go into 25 3 times with 4 left over. And now there's nothing left to pull down, and so 4 is our remainder. So now we know 375 divided by 7 is 53, remainder 4. Okay, something else we want to look at is what happens if the divisor is too big to go into the number you get after you pull down. So let's take a look at that, because this is what leads to students wanting to pull down two numbers at once. So here we have 839 divided by 4, and so we'll set that up. Now this time 4 does go into 8 twice, and exactly. So we have nothing left over, and now we're going to pull down that 3. And now we're going to say, how many times does 4 go into 3? Well, 4 is too big to go into 3, so that might make a student want to pull down a 9. But you can't. You have to have a number up here for every number you've pulled down. So if 4 won't go into 3, we'll have to say 4 goes into 3 0 times. See, that's where we're going to get a 0 up there in the answer. Now multiply back, and of course 3 minus 0 is 3, and now we can pull down the 9. So now how many times will 4 go into 39? Well, 4 times 9 is 36, so 4 will go into 39 9 times with 3 left over. And now there's nothing left to pull down, and now we can say that 839 divided by 4 is 209, remainder 3. Now let's do a few examples with 2-digit divisors, and this is where things can become overwhelming, because once we get past the 1-digit divisors, then we don't know our times tables as well. It adds another layer of complexity to the problem. And so if I were teaching this to a group of elementary age students, I would want to make sure that they're very comfortable with the division algorithm itself. You know, guess, multiply back, subtract, pull down. Guess, multiply back, subtract, pull down. You want to make sure they're good and comfortable with that before you start making the problems harder, because this gives us a whole new set of things to think about. So in this example, we're going to divide 3,475 divided by 13. And 13 is really not so big of a number that we can't do the multiplying in our heads. So I think this is a good place to start. So let's just see. The first thing we're going to need to say is, how many times will 13 go into 3? Well, it won't. So we won't have a number over the 3. How many times will 13 go into 34? Oh, well, 13 times 2 is 26, and 13 times 3 is 39. Now, you might want students to go off on a piece of scratch paper maybe to do that. If they don't know their 13s mentally, then they may have to do some extra scratch work, but this is not really so bad because the numbers are so small. So 13 goes into 34 only 2 times. Let's multiply back. 2 times 13 is 26, and let's subtract. You see why it's so important for students to be comfortable with the multiplying and the subtracting, because that's all built into this algorithm. So now we're going to have to do a little borrowing here. 34 minus 26 means I need to borrow, so 14 minus 6 is 8, and then I won't have anything in the tens place, and I'm ready to pull down. And I like that the 8 is smaller than the 13. That tells me that my guess was correct, and I'm ready to pull down the 7. And now, here, this is a little harder, because now we have to make a guess. How many times will 13 go into 87? Well, if we don't know our 13 times table very well, this can be harder to figure out. Let's say that we guess that 13 will go into 87 5 times. All right, well, multiplying back, 5 times 3 is 15. So I put the 5 down and carry the 1 in my head. And now 5 times 1 is 5, and add the 1 that we're carrying, and we get 6. Now we want to subtract, and we'll find out that 87 minus 65 is 22. Okay, now that's a problem. That's the same problem we ran into before. We need this number to be less than 13. So that tells us that the 5 we guessed was too small. So let's erase. And let's go one bigger. Let's guess 6. So now multiplying back, 6 times 3 is 18. So put down the 8, carry the 1. 6 times 1 is 6. Add the 1 that we carried, and we get 7. Now when we subtract 87 minus 78 is going to give us 9. And that's good, so it's less than 13. That tells us we made a good guess here. We pull down the 5, and now we're ready for our next guess. How many times will 13 go into 95? Well, I'm going to use the fact that I just figured out what 13 times 6 was. 13 times 6 was 78. If you add 13 to that, that'll take you to 91. So 13 times 7 is 91, which is really close to 95. So now I'm going to say that 13 goes into 95 7 times with 4 left over. And there's nothing left to pull down, so 4 is our remainder. And now we can say that 3,475 divided by 13 is equal to 267, remainder 4. Let's do another one with a 2-digit divisor. So we've got 2,579 divided by 32. So I wanted to look at this one with you because this time the 2 digits that we have out here are too big to go into these 2 digits. So 32 is too big to go into 25, so I'm going to have to think about how many times will 32 go into 257. Well, you can see how that would be very overwhelming for an elementary age student. And it even would be overwhelming for an adult if we had to guess it right in our heads. So what we do is we make the problem a little easier on ourselves. Now it's more of a guess, so we have to be willing to live with the fact that there's a larger chance we might guess wrong, but it's still just a guess. Let's not worry about the numbers that are in the ones place. Now, I know 7's not in the ones place for the whole number, but if we're thinking about 32 going into 257, 7 would be in the ones place. So all we're going to think about is how many times will 3 go into 25, because that is small enough that I can figure it out without doing a lot of work. 3 times 8 is 24. So we feel really good about saying that 3 will go into 25 8 times, and therefore it's a reasonable guess that 32 will go into 257 8 times. So I'm going to put my guess over the 7, and now I'm going to multiply back. 8 times 2 is 16, so put down the 6 and carry the 1. Now 8 times 3 is 24, plus the 1 that we carried is 25. And now when we subtract, you can see that we get 1. Okay, that's good because 1 is less than 32, so it means that 8 was a good guess, good for us. But now when we pull down the 9, this is where a lot of students would make a little bobble, because now you want to say that 32 won't go into 19, so the remainder is 19. But we can't say that yet, because remember, we have to have a number on the answer line for every number we pull down. And we haven't put a number for how many times 32 goes into 19. Well, 32 is too big to go into 19, so it goes in 0 times. And now we multiply back and subtract, and there's nothing left to pull down. So now we can say that the remainder is 19. So now we know 2,579 divided by 32 is 80, remainder 19. Now I also think this is a good place to point out that when you're teaching division, it's maybe too time consuming to ask students to check every single answer, but they need to at least know how to check to see if something's reasonable. So you see, like if a student didn't remember to put the 0 and their answer were 8, then they could say, okay, 32 times 8 is not going to be this big. Not even after I add the 19, it's nowhere near big enough. So that should be a clue to them to go back and see what else might have happened. And oh, I forgot my 0. So now let's ask ourselves, would 32 times 80 be anywhere near 2,500? Well, yeah, 30 times 80 would be 2,400. So that puts us at least in the right ballpark. And that at least gives you a little confidence in your answer. Let's just get one more example here. So I have 1,716 divided by 23. And now, how many times will 23 go into 1? Well, it won't. So how many times will 23 go into 17? It won't. All right. How many times will 23 go into 171? Well, I don't know. It definitely goes in, but how many times, I don't really know. So what I'm going to do is the same kind of strategy I used last time. I'm going to ignore the 3 and the 1, and I'm just going to think about how many times 2 goes into 17. 2 goes into 17 8 times. So I'm going to guess that 23 goes into 171 8 times. Let's check it out. 8 times 3 is 24, so put down the 4 and carry the 2. 8 times 2 is 16, plus the 2 that we carried gives us 18. All right, now we have a problem because 184 is too big of a number to subtract from 171. Because 184 is too big of a number to subtract from 171. So that tells me that I guessed too big of a number here. I'm going to erase the 8 and the 184, and let's try again with 7. So now 7 times 3 is 21, put down the 1 and carry the 2. 7 times 2 is 14, plus the 2 that we carried gives us 16. Now we can subtract that and find out that there's 10 left over. Pull down the 6, and now how many times will 23 go into 106? Well, you could kind of use the same strategy that we used before, and you could say, well, 2 will go into 10 5 times. That would not be a bad guess. But when you multiply back, you'll find that that gave us too big of a number. So we're going to have to drop it down to 4. Now, you might also have said, well, another strategy would be to say that 23 is really close to 25. And 106 is really close to 100. And I know that 25 goes into 100 4 times. So you might have thought from the beginning that 4 was a better number. And indeed it is, because when we multiply back, 4 times 3 is 12, put down the 2, carry the 1. 4 times 2 is 8, plus the 1 we carried is 9. And when we subtract, 106 minus 92 gives us 14. So there's nothing left to pull down, so 14 is our remainder, and now we can say that 1,716 divided by 23 is 74, remainder 14. And let's just quickly check that we're in the ballpark. So 20 times 70 would be 1,400, and that's not so terribly far from 1,700, so I at least feel confident that we haven't left off any zeros or anything like that. Now, we've seen several different examples here, and we've seen some different times when our first guess didn't go as planned and we had to back up and make another guess. I hope that when you're teaching this to students that you'll just really encourage them that mistakes are all part of the process, and that guesses that are too small or too large are not really mistakes. They're just part of the trial and error process that we're going through here. But there's a lot going on here. There's estimating, there's multiplying, there's subtracting, there's carrying and borrowing. So it's understandable that a student could feel overwhelmed. What you don't need to do is you don't need to make them feel rushed, and you don't need to make them feel like they're not going to get it. If they're getting stuck on multiplying back, drill times tables. If they're getting stuck on subtracting, then practice subtracting. But these are just all skills that have to be built up in order for them to master this process. It's something very abstract. It's something that's going to come with time. So patience from the teacher, patience from the student, and patience from the parents, I think, is really what the whole thing calls for. Good luck.